All right, awesome. So I wanted to start off with this comic because XKCD is hilarious. Um, and we use Git at a very small level here. But this is beautiful graph theory tree model. I don't even know how it works. It's okay. Really smart people do. And if it doesn't, you just delete it and clone it again. I actually just gave someone this advice earlier today. It was really funny. It reminded me of the comic. So it's okay. Eventually you'll learn, if you're curious enough, how it all works behind the scenes. And I'm glad some people are curious about that sort of stuff because they keep it running. I don't care how it works. I just like that I push the button and it goes out to the cloud and it makes me happy. I'm very much a consumer of software, and I like to make stuff do cool things. So building the tools that make stuff do cool things is interesting too, but that's a whole other level. So I just want to start with that one. All right, so we are officially in the tail end of the semester, believe it or not. Happy November. We've got classes and our last project, individual project here, of the small projects that we're going to work on. And then in 2 weeks, we'll start the final project that you have the last month of class to work on. I'd recommend you work with a partner. It's not a learning outcome, so I don't require it. Next class, we do have to work with partners because one of the ideas is working in a small group is one of the learning outcomes. But at this point, you won't have to. But if you want to, I would definitely recommend it. Generally, 2 heads are better than 1. This is universally true, right? You'll get better ideas if you can talk it through with somebody here. Now, it is a little bit of work to coordinate who's working on what and spending the time collaborating. So if you do it individually, if you do it with a pair, you're still doing the exact same project. Right? It's still about the same amount of work. The work is just different when you collaborate and coordinate with someone rather than just do it all yourself. So just keep that in mind as we go. So we'll get into classes. We'll do a project on classes. We should be able to get far enough today to get you started on that at least. Next week, exceptions and modules, and then we'll touch on files. We'll do some good fun stuff with files. That'll be part of the final project using a file. We won't have an individual project on it as we go. And then we're off for Thanksgiving break. Have a great week off. Eat a lot of turkey or stuffing or whatever you like. For me, it's the cranberry sauce, the cranberry jelly. It's got to look like the can though, with the canned ribs on it and everything. That's the best stuff for some reason. And then the last little bits of topics, we'll get into inheritance, recursion, Python for data science. Again, just sort of introing some of these topics. We'll hit on these more next semester if you continue on. And then the last week of class is just reserved for you to work on the final project and for me to walk around and help people. This is a great time to work with your partner because you're both supposed to be here anyway. And they can't tell you, no, I'm busy, because you literally signed up for a class at this time. What do you mean you can't come in and work? And then on our final exam slot, you'll present your projects. So you'll take a turn going up front and running your code and kind of a brief explanation of what it's doing here. I'm not grilling people on it here. But generally, it's pretty easy to tell if someone knows what their code is doing or not, and if they just copy pasted from somewhere online. Because when I ask a question about their code, they have no idea. Right? It's pretty obvious, right? Let's be honest. So we've got a month to work on it here, and part of the score will be doing progressive commits. So with your project, you commit your code and then you give me the URL. I don't care how many commits you have or anything like that. You could work on it on a single day, you could work on it the whole 2 weeks, whatever that works out. For the final project, you'll have to have at least 10 different days that you've committed code, right? Partly to encourage you to start early, partly to make sure you don't just copy paste a solution from online, because breaking that into 10 different pieces is rather hard, and it's obvious when people do that as well, because then stuff doesn't work. They give me the first 10th of the file. They're like, no, this is not how you write code. So lots of reasons for doing it, but it's a good habit to get into. So you'll have to have the minimum number of commits as well. So that's why we have a whole month to work on it. So out of that 30 days, I figure you can probably find 10 of them to do some work, right? That should work out relatively well for people. And then I'll shut up and you guys will talk. It'll be a lot of fun. Yeah. Okay, no worries. If you think of it, let me know. All right, so we're going to get into classes here. Let's take a peek at Zybooks again, and I'll encourage you to not get too far behind. 3% of labs done for lists and dictionaries. we're still not above 50%, which is, I mean, half of you are showing up. So I imagine it's probably not you folks. It could be, but I don't know that. But half of you are showing up and half of people don't show up. And I assuming they're just not going that far, right? And it gets worse as we get into the further chapters. Oh, functions did pretty good though. They had a little spike in functions. Maybe people wanted some practice with that.
We do them a lot.
Yeah, oh yeah. All right, so we'll get into classes. So the idea with classes is, it's not a new topic, but it's an idea we'll call object-oriented programming, dealing with things as objects. And the reason why object-oriented programming is fantastic is it's a natural way for people to think about code, right? The hard parts of code is really not telling Python what to do. The hard part of coding is figuring out how to take a big problem and break it down into small enough steps that you can tell a stupid computer to do it. That's the hard part of coding. It's the creative process of how do I solve these things. So this is chapter 9, classes. So what object-oriented programming and classes let us do is we get to group things together in a more natural way that makes sense for us to talk about. So when we talk about objects, that's what we deal with every day in the world. So if I say a chair, you all have a picture, an idea of what a chair is. A chair is an object, right? Each different chair might have its own set of attributes, right? Not all chairs are gray. Not all chairs have 4 wheels. Some just have legs. Not all chairs will tip back and forth. Not all chairs will go up and down, right? Different things that chairs can do are their attributes. So when we think about how we can work with representing real-world objects in code, we can use classes. Classes let us turn these things into objects and deal with them like an object. So we're going to write a class for chair. And now everything inside of this class here belongs to chair. And I can make multiple instances of chair and have them all in memory at the same time. So I could have 17 different chairs in here. Most of them might all have the same set of attributes, and that's okay. Some of them might be different, right? There's a chair back there that has arms, right? Your chairs don't have arms. My chairs don't have arms, but chairs can be different, right? So we can have these different attributes. So the way that we do this is we use a special method called the init method, or the constructor. So we're going to define it's underscore underscore init underscore underscore self. We'll get to it later. It'll make more sense when we get there. But this is the special initialize method or constructor method. So when we create a chair in Python, this method gets called. And in here now, the constructor's job, the init's job, is to give all of a class's attributes some sort of value, right? And to say that they belong to this instance of chair, so I can say, hey, this is chair 1, this is chair 2, this is chair 3, chair 4, chair 5, whatever we want here. We say self dot. So anything that is self dot belongs to an instance of chair. And we'll make a bunch of chairs here in just a minute here. So I can say self dot, maybe we'll say color. And for now, I don't know what the color is, so I'm just going to set it to an empty string. But I'm going to create an attribute and give it some sort of default value here. So this is the initialize constructor. Its job is to give attributes names and values. Right? So we've got color, and maybe we have height. And if you're anytime you're measuring something or have a unit, you should specify what that unit is in. Now, cm is probably pretty clear that that's centimeters. I'm okay with this one. If you want to spell out centimeters, that's good too. But cm is probably pretty clear that we mean in centimeters here. And maybe we'll say, I don't know how tall it is. 0 might not be a good default, but it's okay. Well, sure, we can sit on the floor essentially at that point here. And then other things about chairs, like has arms, right? We'll say, how about false is our default? Most chairs don't have arms, but some chairs might have arms, right? We can do that. Now, for chairs that go up and down, they have a minimum height and they have a maximum height. And you can adjust it somewhere within that range, right? So if we want a chair to be able to go up and down and be able to change its height here, right? Because some chairs have that fun lever. We can add attributes for that. So we'll say a minimum height in cm. Again, probably 0. And then maximum height in cm. I don't know, 100, a meter? something that makes sense, right? We don't necessarily know right now for chair. For other objects and for other classes, we might know some good defaults. Chair is a little bit weird here, and that's fine.
Can you do inches or?
Sure, it's your code, you can specify. But the imperial measurement system is just stupid, and I hate using it. My personal crusade to move to the metric system has not gone well, but I will continue using it, and because it's just such a better system, right? Base 10, right? It just makes sense. I don't know. There's the joke. I don't know, someone had there's a funny comic about how you can remember how many feet are in a mile, and it's 5,280 feet in a mile. It's something about 5 potatoes or something like that. And then they're like, well, how do you know how many meters are in a kilometer? And they're like, 1,000, because our system isn't stupid. You don't need to remember 5 dozen potatoes or something. Like, why? Such a terrible system. Like we had a chance in the 70s to move to the metric system, and we decided not to because Congress is terrible at getting literally anything done. But that's another story for another class. All right, so here's our chair. So once we have a chair, we've got a bunch of values now. Okay. So this is our initialized constructor. Most languages call them constructors. It's init in Python here. Now, to use chair somewhere else in our code now, I can say, hey, I want a chair. So to do that, we'll say this is Eric's chair equals chair. And I use a set of parentheses here. So this will call the init method here. So this calls the init method. Okay? Then from here, now I can say Eric's chair dot, and I have access to all of its attributes. I can say Eric's chair color, Eric's chair has arms, Eric's chair height in centimeters, maximum. Any of these values now, I can go and access. And it will have its own set of these values here in memory that I can get at with a single object or a single variable here of Eric's chair. Now you might think, hey, I could have done this with a dictionary. I could have a dictionary and it could have a key of color with an associated value and a key of height in centimeters with an associated value. That gets to be a big pain in the butt to use a dictionary and have all those keys and values, and then if I type them the wrong way, it's going to get really screwy. This way, I've got a standard set here of attributes. So I can go and say, hey, Eric's chair is blue, and Eric's chair height in centimeter, or has arms, mine is false right now. It's already false, but it's okay. Setting the values again is probably a good thing to do here. Height in centimeters, we'll say mine is, I have no idea. This is probably 70 centimeters. I'm just gonna guess here. And Eric's chair dot maximum is 70, and Eric's chair minimum is 70 as well, because mine doesn't go up and down. Right? There's no adjustment. When we get to the lab and my chair goes up and down because I have the lever, then we could give it some different values, those sorts of things here. So I created it gets some default values, and now I'm going to go set these specific values. Because here's this instance here. And I can go make someone else's chair. I can do Jeb's chair. Let's do Jubilee. We just bought her an orange chair because she wanted orange for her room. So it's cheap on Amazon is amazing. And they've done a really good job. I'm so lazy now, I don't even look at other websites. I'm like, hey, I can buy it on Amazon. I'll get it in 2 days. I'm not going to shop around to see if I can get it $5 cheaper somewhere else. They've done a good job of that. They got some people hooked at least. Anyway, so hers chair here, and then Jubilee's chair dot color is orange. And again, we just set a bunch of these things. I don't know. So hers does go up and down here. It doesn't have arms. So we'll say maximum is probably a meter, and lowest is probably 30 centimeters. I have no idea. We're just making it up, right? This doesn't have to make a lot of sense right now. Right now we have 2 chairs. Okay. We should change that to Jubilee's chair. There we go. So when you copy paste, make sure you change your variable name.
Do you want to change the height in centimeters as well?
It's probably at 70. I could, sure, we can put it somewhere else. We'll say it's 50 or 60. Yeah. So it'll have its own set of values. And then I can print Eric's chair, and I can print Jubilee's chair. And when I run it here, we get garbage. Oh, sad. When you print an instance of a class or an object here, right? This is a chair object. You get chair object at, best I can tell, this is its memory address. So this is the memory address that my operating system gave Python to store Eric's chair. Cool, right? So when it created an instance of chair, Python says, hey, operating system, I need a place to store a chair. And by the way, it's also going to store a color, a string, it's going to store an integer, it's going to store a Boolean, another integer, and another integer. All of these things will be handled by just asking for chair. Right? They all get allocated, which is really nice. So if I run this in debug mode, and debug mode is your best friend once we get to this. Now I see Eric's chair and Jubilee's chair. Now sadly, this doesn't zoom, and I'm sad about that, I'm sorry. So it's a little small, but we see again, here's the chair object at this memory location, here's this chair object, but you can expand it and you can see all of its attributes. So each instance of a class has its own set of attributes. So I could have 30 different chairs with 30 different sets of attributes here, and each of them will be individually unique, which is nice. So all of this stuff gets stored in memory somewhere, and Python can go and access it, and I can get these values here. So this is a nice way now, if I wanted to do something like to make printing a chair easier, I can write a function. I can define print chair that takes a chair, some chair, right? You give me some chair, and I'll go print it out. So here I'm going to print, here's the, I don't know, color. We should do this as a formatted string, right? This will be my somechair.color. Now, when I first type somechair dot, Python has no idea what somechair is, right? Because it has no idea, right? Because I could give it anything here. I can give it a string, I can give it an integer, I can give it a float. It doesn't know, right? So it's the type ahead is not going to be great here for a little while, but eventually it figures it out here. So here's its, I don't know, what, current height or something is somechair dot, oh, it doesn't even get it yet. Height, oh, is it height? Yeah, it didn't figure it out yet. So you can suggest to Python that this should be a type of chair. I think is it with a colon chair? Chair, an arrow? I think it's a colon, yeah. So if you want to specify that your type of variable should be this type here, so when somechair should be a chair, or like, hey, it should be an int, right? Again, that doesn't make sense for these ones now, but if I say chair, right? Now these will make sense, and now my type ahead is going to work for me here. Because I've told Python, hey, what they're giving me should be a chair. Now it doesn't stop you from doing bad things, like print chair given like 2 or 1 here, right? Now it's going to say here, expected type chair got int instead. It's a warning here, but it still runs, and then it crashes. And it says, hey, int object has no attribute color. When you say somechair.color and you give it the integer 1, there is no .color attribute. It will just crash on us here, right? But now if I run it with Eric's chair and Jubilee's chair, we get, here's the color blue, height is 70, here's the color orange, height is 60. We should probably specify that's in centimeters, right? Height in cm. Lowercase? I forget. There we go. Again, I'm just being pedantic about units here, but it is very important. And we actually did crash a rocket ship because NASA and the European agencies we were working with didn't do the right conversions. I think it was us not using the metric system that screwed it up, I'm pretty sure. That's worth looking up, right? Yeah. NASA crash. Metric system. So let's see if we get a hit here. Yeah, here we go. Biggest face palms of space flight history, part 2. How NASA lost $327 million mission to Mars. All right, that's a video. I don't want a video. When NASA and Lockheed Martin mixed up units for the Mars Climate Orbiter. Where is there, like, telling us what, it doesn't tell us anything about it, does it? I want to know what it was. Ah. Oh, that's some details about it. Which one did they screw up? Course corrections. This was a while ago. Tracking space. Okay, here we go. They were tracking it in metric, but they were actually getting back our imperial units. So they thought it was going the right way. It was not.
Didn't double check.
I know, right?
They're like so smart, and that's the one thing that screws them up.
Because you'd expect everyone uses metric.
Yeah.
But if someone decided to use the imperial system because we're stupid and we think our unit of measurement is so much better than everyone else's, like there's some fun maps, right? Fun maps. Who uses measurement? I can't spell, but hopefully you got it right. Here we go. Here's the map. I don't know who this is. This and crazy where they use both. Is it? Okay, I'm terrible at geography. Countries that use the metric system map. That's just the map here. Yeah, like, come on. Why have we not changed now? Oh, here's another one. I hate that like clicking on it doesn't actually make it bigger. That's fine. Anyway, so we should specify our units. Doesn't mean we're going to get the right units, but so we can create a object, we can create a class that lets us model something in the real world, and it has all these attributes, which is great because these are ways we can group it together and not have to use a dictionary. Saves us a lot of time, energy, and effort, and then makes sure that all these attributes match here, because if we used a dictionary, you could typo something, and you might say color, and you might spell it color if you're feeling British, right? Sure. You know, we don't want any issues with color here. Don't do it wrong. So that's one way it just makes life easier for us to do all these things. The next thing, and when we talk about object-oriented programming, one of the principles of object-oriented programming is something we'll call encapsulation. It's a fancy technical term. We'll get more into it next semester. But the idea is we're going to encapsulate, we're going to take all the details about something and put it into one nice little package. Right? So we've encapsulated everything about chair into a chair class. I have all my attributes here, and then other things that I can do, I can define other methods or other functions here of ways that you can interact with chair. So I can say, hey, let's make a function here of this chair class called, how about change height? Now, the first argument here in class functions are always self. There's a reason here, don't worry too much about it, kind of magic, but it's always going to be self so that you have access to all of your self attributes. If you don't have self here, you won't be able to get at any of your attributes and you'll be sad. So it's always self, and then maybe we'll say change in CM. So you can tell me how much to change the height here in centimeters, and I'll try and change the height. But what we're going to do here is we're going to protect the integrity of our class. If you try and change the height higher than the maximum, I won't let the chair go higher than the maximum because we'll just say that's physically impossible. And if you try and change it lower than its minimum, again, we'll say that's physically impossible. You can't do that. So we are now able to add some protections into our code to make sure that values don't go out of bounds. So if we have bounded values, we can make sure that the values stay within bounds, which is super important for anything that matters if things need to stay within bounds. And we're taking user input or dealing with, hey, the user wants to change their height to make it 3 meters tall. Sorry, your chair doesn't do that, right? We can control these things in our code to make sure that they don't get screwed up, because we're going to get weird stuff all the time. So we're going to say self.height in centimeters. How about plus equals the change in centimeters? So if you want to give me a negative number, we'll go down. If you give me a positive number, we'll go up. Hopefully that makes sense. We could also make a go up and a go down if we cared to, but I think change is probably easier for us here. That's fine. So I've changed it. Now I want to make sure we're within bounds. So if self.height in centimeters now is greater than self.maximum height, let's just go change it. We'll say, okay, well, you tried to go higher than the highest here. We'll just stop you at the max. Oh, you wanted to go up 3 meters? Well, you can only go to 1 meter, so we'll just stop you at 1. Right? We'll say you tried to keep going, and when you just stopped at the top here. Okay? And then we can check if self.height in centimeters. Probably an else if, right? Because if it wasn't higher, it can't have been lower. If it's less than the minimum, then again, we'll just set you to minimum. Right? If you tried to go too low, we'll just say, nope, you stopped at the minimum. So what we can do here is we can protect the value of our current height. Right? Keeps it in bounds. To make sure that when you go and change it, you can't give it a bad value. Now, this is a little bit silly at this point here because I can just go say, hey, height in centimeters is 700. Right? this doesn't keep me from setting the value bad, but it means when I use my function for print chair or change height, then I can't get it badly. So what we get to do now is we get to hide some of these values here. So when we're encapsulating all of our details into a class here, we can also do something called abstraction. It's another principle of object-oriented programming, is we're going to hide away all the details that you don't need, right? So when we use classes like random and we get a random integer, we work with it abstractly. You don't know what randint is actually doing to give you a pseudo-random number. You just know it gives you a random number as advertised, and we're happy. So the class for random, we work with in an abstract manner. We just know here's a function, it does what it's advertised, I don't care how it gets the job done. So we're going to do that similar idea here, where we're going to hide some of our implementation details. We're going to hide some of the things away from users so that they can't do bad things with it here, and we'll just let them use our public functions here. So in Python, we're trusty. Python assumes people will do the right thing and not shoot themselves in the foot, but you can if you try hard enough. So what we can do, if you want a value to not be visible to users, you put an underscore in front of it here. So if I say self._ height in centimeters, so you prefix with to hide the value, or make it private. Is in other languages you can say it's private and then they physically can't change it. Again, Python, all you do is hide it, and we assume people won't go mess with it here. So now when I'm playing with chair here, and I say chair dot, where's my, did I mess it up here? Height in centimeters? Height, oh, here we go, height in centimeters. I just had to change it a couple places here, sorry. You know what, I should have done it the smarter way. Here, one sec, let me go do this. So if I want to rename a variable here, and I don't want to have to go copy paste a bunch of times or go find all the places I screwed it up here, I can right click and go to refactor, rename here, and I'll say, hey, rename it to height in centimeters with an underscore. And now it's going to go fix it all the places for me. Right? Use your tools, save yourself some time here, but I'm going to pretend this line doesn't exist here for a second. We don't want to do any of those. Okay, so now I have a private hidden height in centimeters. So when I go work with a chair and I say Eric's chair dot, I don't get anything with an underscore. The tools know that that means it's private. I shouldn't advertise that it's there because I don't want someone to go and mess with it. So the idea here is when we're writing our class here, we've encapsulated all of our details, we're going to work with it abstractly, we sort of have this contract. Say, if you just use the things you're allowed to touch, it will do as advertised. Right? If you go open up the phone to try and replace the battery, you voided your warranty because the right to repair doesn't exist in America. But if you void the warranty and touch things you're not supposed to touch, then I can't guarantee it'll work as advertised. Right? Nothing stops me from saying, hey, here's my height in centimeters is 700 here. Python will let you go do bad things here. But we shouldn't, because that voids the warranty. Right? If we go and physically set it to a bad value, the class can't protect itself from that. So let's just pretend we don't do that, okay? So I set a maximum, I set a minimum here, and then let's go say Eric's chair dot. Now I can say change height. Now, when you call a function here, even though it says self, you don't have to give it self. This is implicit. So the Eric's chair here essentially gets plugged in as the self. So instead of saying change height, give it Eric's chair and something, right? We just say Eric's chair dot change height, and now Eric's chair is the self that's given here. And I'll say, hey, let's just change it. It doesn't really matter what I give it here because it's going to stop at 70, right? When I try and change one of these values here, because it'll either be higher or lower. And then for Jubilee's chair, we'll go Jubilee's chair dot change height. Now let's put hers at like 50, right? If it starts off at 0 and we want to change it by 50, it should work and it should go to 50, right? Should. Let's see what if it prints out here. You say, okay, cool. So Eric's chair landed at 70. Now, if I hadn't called change height here, it's going to be at 0, which is kind of bad still because it's not between the maximum and the minimums. But again, we can do bad things if we try hard enough. Okay, so now we get here's the color, here's the height. So we've hidden this value away. Now, if I want somebody to go and get those details, though, I don't want them going and accessing it like this. Because even PyCharm is warning you, hey, you're accessing a protected member here. It's supposed to be protected, it's supposed to be private, you shouldn't be touching it here, right? Again, you're breaking the warranty. So what we want to do then is we want to give a public function to go and get that value. So we'll have a get chair or height in centimeters, height in cm. So this is a get method. So if you want to give someone access to the value that you're trying to hide, you give them a public function here. And we just return self.height in centimeters. So this gives them public access to a protected or private value. So they can go and get at it now. So now I can say some chair dot get height in centimeters. Again, we don't have to give itself, right? Because it's whatever the chair is that I was given here. It will go and get that value back out. So I can give you access to that value here, and we're good to go. So here's chair. Now, technically you can paint a chair and change its color, but let's pretend for a minute that once a chair is gray and blue, it's always going to be gray and blue. Because really the paint is just a covering and we could peel it off if we care to, right? So I'm going to do the same idea with color here. I'm going to make it private so you can't go change it here. But how do I give it its initial value, but I want it to be set once and never changed? Well, now I can say, hey, let's add an argument or a parameter to my initialize, to my init method, to my constructor here, and say, give me the color. And I'll set the self.private color to the color argument. So when you make a chair, you tell me what color it is, and then from then on out, it's never changing again. Because we're going to pretend like you can't put paint on it. Right? So if I make it private, I need to give them public access to it. So we'll say get color, return self.color, color, right? If we want to be fancy again, we can do that. And then we'll change our method here. So this is get color, right? So now I can't set the color to blue. I can say, hey, chair, and now chair's warning me here. It's saying, hey, parameter color is unfilled. It was supposed to have a color here, you didn't give it one. So we'll say, okay, Eric's chair is blue, and then I don't need to set color here. And then Jubilee's chair is orange. I don't need to set color here. And now I have a blue chair and an orange chair, and I can't change the color again. I don't have access to one of these things. But now let's change our mind. Let's say, hey, maybe it makes sense that you can change the color of a chair. Right? Why not? Because we can throw some spray paint on it. It'll probably stick. So if I want to give someone access to change a private value here, we can give them a public method to do it. We'll say, how about set color? Given a color. We'll say self.color equals the color. Right? So if you give me a color, I'll set my private color attribute to that color. Now this feels like a lot of work for something that can really be anything here. So color's not the best example of it here, but say we only had like a certain set of colors you could pick from. I only sell chairs in gray and black and blue and brown. Right? So we could say here when you go to set the color, hey, if the color does not equal gray or the color does not equal blue or something, right? We could give them a warning and say, hey, that was invalid. We could do something about it here to make sure that the integrity of our class is protected. Right? If it's a bad value, throw it out, throw it away. Now for set color, we don't really care, right? So we can change the color if we want here. That one should be fine. Getting the height in centimeters, right? You access it by changing the height. Is the only way we can go and change these things by using my public function here that does the bounds checking, right? So something, let's do another one here. Let's make a lotto ticket class here. So if we're to write a class for lotto ticket here, we'll define an init method here. Now, when you make a lotto ticket, you're not allowed to change your numbers, right? That's probably would make a lot of sense. You don't want someone to go change the numbers once they've created the lotto ticket, because then we'll just make all of ourselves will be winners. And if everyone's a winner, no one wins. That's a good rule of thumb for you, by the way. So let's set some numbers, right? So we'll say number 1, number 2, number 3, right? Sure. And we'll say self.number1 equals the number 1. That was weird. Self.number2 equals number 2, and self.number3 equals number 3. Okay, so I can set 3 numbers when I pick a lotto ticket here, just a 3-digit lottery, nothing too interesting, and then we'll define a get number 1 function here that returns self.number1. Right, I don't want them to go change it here, but they need to be able to go and get these values back out here. And we'll get number 2, return self dot number 2, and we'll define a get number 3, given self, return self dot number 3. Okay, so I can get 1, 2, and 3 back out here. So I can put all these things together in the lotto ticket, and I can go and set them. Now I probably want to sanity check this at some point, right? And make sure that these numbers are valid here, right? So we should check. We can say, hey, if we want what? 0 is less than number 1 is less than 10, right? If you're 1 to 9, then this is good here, right? We'll take it. If you don't give me something that's valid here, well, for now, maybe we'll just set it to, we'll give you a default here. Oops, number 1, maybe we'll say you get 0. If you try and give me a dumb value, you're stuck at 0, you're never gonna win. But that's your own fault here, right? And we'll do that again for each of these. Or if I have the same code more than once, I should feel bad about myself, right? Right? So what could we do instead? Well, we could validate the number here, right? So we could write a little helper function. So classes can have their own functions here. And if it's just a little helper function, like, hey, I want to go and validate that this number is valid, I don't want someone else to go and use it here, right? Because no one else needs to know how we validate. They don't need to know that implementation detail. So we can hide functions as well. I can say this is a validate number with an underscore given a number, right? So that will not be visible then when someone uses a lotto ticket. We're going to hide it here. This is a private helper function because we're the only one who's going to use it internally. We're just going to use it in our class here. So I can say then self.number1 self.number1 is equal to self.validate number given number 1. So my validate number then can go and do that checking. We can say, hey, if 0 is less than number is less than 10, return number, otherwise return 0. Now, you might be tempted here to put an else return 0, but the else is redundant, right? Because if it hit a return, it's not going any further here. So generally, you can skip that one here. Right? It looks a little bit funny, but this is much more common and avoids a little bit of redundancy. And hey, if you have to type 4 less letters, you've saved 2 seconds. Great. Okay, but you'll see this. Again, like if you say if true, return true, else return false, same idea. Just return the thing, right? Just saves you a little bit of time here. So each of these then, we just go and validate now. Right? That way we don't have the same code twice and we feel better about ourselves. Like, hey, we're using functions. This is a private function in our class. It's great. Now, it's suggesting it might be static here. Don't worry about that. We'll get into what static means next semester. It just means you don't need self. If you don't have self, weird things, you don't worry about it. It's okay. This is also really clear who copy pastes code from online and just doesn't know what's happening here because most of their functions become static. Because they're like, oh, yeah, this is what it's suggested. Right? Okay. So sure, we can validate, we can get our numbers back out here. Now we can also figure out if we're a winner. So here's where classes get really interesting here. So here's one lotto ticket. So I'm going to define another method for isWinner given the winning ticket, which is a type of lotto ticket. Right? We'll say, hey, I want a winning ticket. I want it to be a type of lotto ticket here. Should work for me, right? Why is it complaining? Maybe once we finish it, it'll be happier here. So I can check, do my numbers match, right? So if self.number1 equals the winning ticket dot get number 1, right? And self.number2 is equal to the winning ticket dot get number 2. All right, why is it complaining about that? Maybe I can't tell it its own type here. That's fine. We'll make it work, right? And again, for number 3, oops, let's do number 3. If number 3 matches here, matches number 3, we return true. Again, we don't have to do that, right? Just return, right? Don't even say if, just say return. If 1 matches 1, 2 matches 2, 3 matches 3, return all of them here. If all of them match here, we're a winner. So I can give you another ticket, and this ticket will compare itself to another ticket here. So I can make 2 lotto tickets here. So we'll make a lotto ticket, here's Eric's ticket equals a lotto ticket. And I'm going to give it 3 numbers, 1, 2, 3, right? And then I'll make a winning ticket equals a lotto ticket. Now this one I want random numbers, right? So let's go and import random here, up at the top. Import random. And then our winning ticket then will be random.randint 1 to 10, 3 times. Do, do, and do. Right? And then we'll see if I won. So we'll print Eric's ticket dot is winner, given the winning ticket. Now the chances of me winning are pretty low here, right? We can all do stats, but most of the time it's going to be false, 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 false. Oh, bummer, right? Okay, well maybe we don't want to make it random here, so maybe we'll do a, this is my cheating ticket equals a lotto ticket given 1, 2, and 3, and we'll say, okay, am I a winner then if I assume the cheating ticket is the winning ticket? Yeah, that one should be true. And I get back true. My numbers matched, right? So I can make a bunch of different lotto tickets and say, hey, how many lotto tickets do you want to buy? So let them spend as much money as they want on these things, and then get a winning ticket and compare them all and see how much money they won, right? This is a very fun exercise for people who like playing Powerball because they can pretend to lose money and not actually lose money on Powerball. And the state makes so much money off of this, it's ridiculous. And it's really sad. They're like, oh, it's good because we give the money to the schools. So you should go spend your money on Powerball. But the people who play the lottery are the people who don't have the money to spare to play the lottery. And it's just a tax on poor people who don't know any better, which is really unfortunate. I worked with a lady years ago, and her retirement plan was the lottery. Like literally, she would buy 2 tickets a day. And she's like, eventually I'm going to hit the lottery and I can retire. It's like, lady, look at how much money you're spending in a year buying 2 tickets a day. She's like, oh, that's a lot of money. And then she stopped for like a month and went right back to it. Yeah, it's sad.
They have hope of winning. That's what it is.
Yeah, and people do win. It's true, people do win. Most of the people who win don't know how to handle money because they were poor already and never had good money management skills, which aren't necessarily a causation. That's more of a correlation, I think. Possibly. There's a lot of stuff here. I'm getting into social science that I know nothing about. But most people who win the lottery don't do very well because they just blow it all right away. Those sorts of things here. But you can make a little simulator here, and we can let people play the lottery and be like, hey, play Powerball all you want here. Yay, eventually you win. And the 1.2 billion in one odds or whatever it is here, right? Chance of winning. Eventually you might win, right? So we could do something silly here, right? We could say, let's make another ticket. So we'll say, how about, let's do this. Did win is false. And while not did win, all right, this feels a little bad here, but that's okay. While we didn't win, we'll keep doing this. So we know what the winning ticket is, so we'll make a new ticket. New ticket is a lotto ticket, given random, and I'm just gonna copy this line here, right? Make a new ticket here, and then my did win will equal the new ticket dot is winner given the winning ticket, right? And then we can count this is number of tickets is 0, and every time this thing runs here, we'll take number of tickets plus equals 1, and eventually we'll print you won. It only took number of tickets tries, right? Eventually we'll win here, 990. Wow, that's more than I thought. Wow, that's bad. All right, 750, that's a little bit closer here. 2,000, oh geez. 450, okay, right? Because it should be about 1 in 1,000 wins, right, with 3 digits. But again, we might get the same new ticket more than once, right? That time we had 2,000 without getting the actual winning ticket because it's pseudo-random, right? So this just lets us play 1,483. Okay, all right. Great. 2,000, 1,000, right? Well, eventually we might try and hit a winner. So if we did this with Powerball odds, we could run it 1 billion times and eventually probably hit a Powerball winner at some point here, right? But we could, right? Or we could simulate something from real life with code. this is where it gets really interesting with object-oriented programming, because I can take a real-world something and write code that models it. And if I can write code that models it, I can do something with it now, like run a simulation. Right? Some things are mathematically hard, especially for me who's bad at math. Right? So if we wanted to do something like, what is the most common space that gets landed on in Monopoly? Mathematically, I have no idea how you would figure that out. Yeah. Yeah, so like, there's ways to do it, but like, I have no idea. And there's a really cool video. One of the guys, I don't think it was Veritasium, one of the guys who does a bunch of math videos, did a Python simulation for Monopoly, and he put in the community chess cards and the chance cards that eventually will send you to St. James Place or send you to jail, and got it all modeled in Python code. It was like, okay, let's run it 10,000 times and see what square gets landed on the most, and like counts every time it lands on a square. It's a big problem, but he break it down into smaller and smaller steps. He does the whole thing. It's really cool.
Isn't it really long?
It wasn't super long. No, I think it was only a couple hundred lines of code, maybe like 200-300. Yeah. What was it here? Python code simulate Monopoly most landed on square. We'll see if we can find it here. Someone did. I don't want. All right, there's tons of them out here already. I want the video here though. YouTube video. Come on. Is this gonna testing Monopoly with Python? Is this it? No.
Hello.
Oh goodness, that was loud. Games computers play. All right, I don't. Monopoly. The most landed on square. It was a good video. The guy does a bunch of good ones here. All right, I'll have to find it for you later. Someone does a good one. Math, maybe? All right, it's not worth. But anyway, you can take something that's complex, and we can make a model of it here, and we can make it work, which is super cool. And eventually, we'll do this kind of thing for our final project because it'll be a lot of fun. I promise. So again, a 3-digit lotto is pretty simple. There's not a whole lot of stuff going on here, but we can make things more and more complex. We can make chairs, we can do cars, we can make trees, I don't know, any sorts of things. Yeah.
For the final project, this may be a stupid question, but could we use Kaggle if we want to make things fun, like grab some data from Kaggle?
So it won't be one that analyzes data. No, we're probably not there yet for most people. If you want to do something fun, we can talk about it later. But yeah, I think that probably more advanced than what we're looking for at this point here. But yeah, Kaggle has all sorts of fun data sets. And that's the fun part of data science, is like looking at data here, which is really cool. All right, so we can model different things. That's what we'll practice in lab. We'll build something, and we'll make a little model of it here. We'll do something with our constraints. This idea, right, like, hey, you can't go above max, you can't go below minimum, those sorts of things here. There's a lot of things we can do with classes, right? But if we look at our ideas with object-oriented programming, we're going to encapsulate all those details, put it in one nice little package. We've got all of our attributes, and we've got the public functions, right? And we can interact with it abstractly. I only need to know what the public functions are, the public attributes are. Everything else that you want to hide away is fine. Hide away the details and protect the integrity of your class, right? When we're encapsulating all those details, we're making sure we don't get into a bad state, right? And there's lots of things like, so if we're flying a plane, right? Planes on autopilot shouldn't go above a certain altitude, right? So the code for autopilot should make sure that the desired altitude never gets too high, right? That's just something we can protect in there. We're not just going to go plug in a number and it'll just go do it, right? Because if you punch in an extra zero, hey, take my plane up to 45,000 feet, and you punch in an extra zero, it's going to go real bad for you, right? Real fast. Those sorts of things. So we can protect to make sure that whatever input we're given, we're controlling to make sure it doesn't go out of bounds, right? We got a lot of good stuff we can do with that one there. So let's talk about the project. Should we talk about the next project here? Give me a second. I got to make a classroom GitHub link. 501, fall 2024. This is project 3. I can't spell my own name. It's so sad. Python template. If I just hit enter, I think it'll find it, right? think it does. Oh goodness, that was weird. Python template, private. See if that works. Yep, there we go. All right, and then we'll go make a new assignment. I got project 0 scored for you guys. I got to work on the 1 and 2 that just came in as well, but 0 should be in for you. I think I'm mostly up to date on labs. It's not too bad. All right, last project. So here is project 3. This will be in 2 weeks at 12:30 p.m. right before the start of class. We'll get this one in, and I think this one's probably. Is this one 20? Might be 20. I think it's worth more points. Please submit the URL to the repository and add screenshots of it running to the README. And a self-assessment using the rubric. Do you guys like seeing the rubric and doing those? Okay, cool.
Yeah.
Usually those are pretty helpful. And if you forgive me, again, I'm just going to go copy paste. I'm going to go pull up last semester's. Here we go. Classes. Yeah, 20 points. Here we go. All right. We're going to build a little shopping cart. Okay. We're going to have a class that has instances of another class. So a shopping cart will have a list of items. So the first class then is for item, has quantity, name, and unit price. Okay? So we'll have set and get methods for quantity and unit price, and just a get method for name. Right? Once you make something called a banana, it will forever be a banana. Right? It doesn't make sense to change the name of these things. Right? Once you put a product on your shelf with a name, that name stays. Right, so this is one of those times it doesn't make sense to have a set. We just want to, here's the name. Good, so if you are going to set it once and never change it again, it has to be an attribute or an argument, a parameter in the init method, right? But your unit price can change, right? Maybe we'll put something on sale. So unit price should be changeable. We should have set and gets for unit price. And the same for quantity. Hey, I now have 3 bananas on the shelf, or now I have 1 banana on the shelf, or whatever it happens to be, right? I've got 5 dozen packs of ramen, right, at 15 cents each, whatever it happens to be, sure. And then we're going to add a function get total price, which returns the quantity times the unit price. So if I'm going to take 10 packs of ramen and put them in my shopping cart, right, I'll have one instance of the item class, ramen noodles. The beef flavor is the best one, of course. The chicken's no good. Don't get the chicken flavor. My kids like that. I don't know why. It's just not good. Times 15 cents a pack, right? Now I spent, so the total price should be $1.50. Right, should give me back that. We're going to add this string method. I'll show you what this one looks like in a minute here. Returns a string value with all the details and total price, like 7 bananas at 30 cents each. Total price is $2.10. Right, pretty looking string. So this string method here, right, we had to do this silly print chair, which was kind of obnoxious here, because when I printed chair, right, we got garbage out. So if you don't want garbage when someone tries to print your class, you can make a special method. So you define under str for string, and this is saying if you want to turn this instance of an object into a string, what does that string look like? Right? What is the string representation of this self instance of the class here? So you return a string, a formatted string, and again ours just had color and current height or something, so we'll say color self.color, and we'll do it all on one line because that's easier. Current height self.current height. Height, that's right, height in centimeters. Okay, again, we can add anything we wanted here, right? Whatever we want here. So this is how to represent the instance as a string, works with print. So now if I say print chair, right, let me make some chairs, print chair here, or if I just say now print Eric's chair, I won't get garbage. I can print Jubilee's chair, I won't get garbage, right? This uses the string method, right? If you put something in print, it implicitly tries to convert it to string. Remember in Python, you can convert something to string. You can say str of something, right? When you put it in print, it just tries that automatically. So it's the same as saying, hey, I want a string of Eric's chair, right? It's just implicitly happening. So we don't have to type it ourselves here. So now I get the string version here, like that. Or we could do it for lotto ticket, right? So if I wanted a string of my lotto ticket, define string here. We're going to return, again, it's always a return, right? Because it needs to give the value back here. Here's, I don't know, self.number1, space, number 2, number 3, I don't know. Does space separate? Probably. Number 2 and number 3. Right, so eventually maybe we'll print the winning ticket. Oh, the winning ticket, 694, 67 tries. Ooh, 67 tries. We got lucky really quick that time. That was nice, right? And if we wanted, we could print every ticket here, right? We could print the new ticket every time, right? Eventually one of the matches, right, out of 153. Oh, we're getting really lucky, right? Right? So you can get a string version of that here. So for item here, you'll get whatever number, quantity, item name, at unit price, each, and total price, right? Now, you don't have to do the arithmetic twice. You can call your own function here. You can call get total price in your string call here. Right? Then we're going to write a class shopping cart. It has an attribute, which is a list here. We're going to put a bunch of items into that list. So we're going to add a public function for add item that accepts an item to add to the list. Hey, you want to add an item? Give me an instance of item here. And then we're going to add a function for receipt, which returns the string value. Doesn't print, it returns a string. Right? That return is important here. Each item with its details and total price. So for each item in your list of items in your shopping cart, we're going to get its string version here, and then a grand total of all the items. So as we're going through, we need to get the total price of each item here to get our grand total, calculate the grand total for the receipt. Then we're going to write unit tests for these. We haven't talked about unit tests yet. We'll get to that on Wednesday. But don't worry, we'll get to it here. Then, now that we have a shopping cart and a unit item class, we're going to write a program that lets someone go shopping. They can put whatever they want in their cart. Okay, what item is it? Anything they want to say is fine. We don't need to have a list of actual valid items or anything like that. And then once they're done, we'll print out the receipt for them. All right? So let me do publish on this, and then I got to add the rubric for you here. So this is project 3. And this is, I think, was 5.8. Yep, easy. So item class was 5 points here, and use this for grading. The shopping cart class was 5 points. The unit tests for item and shopping cart, shopping cart, 5 more points, and then the program, I just copy that, that's probably easier. That lets you shop and print the receipt. 5 more points. So we get 20 points for this project. So if you didn't do as well on any of the earlier ones as you wanted, this one is worth more, right, out of the total points for that category. And that'll help with that. This is not crazy hard. It's not meant to be super hard, right? This is, let's go and put some of these things into practice here and practice them. 2 weeks should be lots of time for this. Unit testing is weird. It's going to feel a little weird, so when we get to that on Wednesday, don't worry, we'll get to it, we'll start practicing it, we'll start doing it. We'll probably do some unit tests in our lab the following week, because there's not a whole lot to do with modules and exceptions, so we'll do some unit tests as well for that. And then we'll practice all of this stuff in lab. It should be great. Okay? All right, awesome. So we got ending a couple minutes early. We'll head over to the lab. I'll grab some coffee on the way. And then we can practice writing classes. And this will be our last project. We've got a couple more things, 2 weeks for this, then the final project coming up. Got a month long for the final project. We're already looking at December 18th when the class is over, believe it or not, because it's November 4th. So we got the rest of the year planned out. Awesome. Thanks, folks.